Hello everyone. This video is a continuation of a recent video where I provided an introduction to file I/O in Python. In that video, I specifically went through the three-step file processing template for reading contents from a CSV file. Here was the dummy CSV file that we created so that we could read in the values from data.csv into a 2D list called table. We did the bulk of that work in this read table function. Now, when I run this code, you can see down here in my output, I have a header, which is a 1D list storing the names of the columns, stored separately from table, which is a 2D list of rows, where each row is a 1D list of values. And those values have mixed type. Some of them are strings, some of them are floats, because we purposely made column 1 a numeric column so that we could go through and see a try except statement in action, where we were converting these numeric values truly into float types. We didn't want to store them as string types in case we wanted to do arithmetic with them later. Now, this video. What we want to do in this video is write the table, header, and data to a file. There's many reasons why you might want to do this. Perhaps you just want to make a copy of a file, or maybe you've got some data you've either loaded in from a file or gotten from the user, or maybe parsed from the web, or maybe got from an API, and now you want to write it out to disk so it's stored persistently. So in our case here, we're just going to simply make an exact copy of what we read in from data.csv and stored in table in a file called datacopy.csv. So our goal truly is to write code that will produce a new file that stores all of these values in this exact same format. So we're going to write a function called writeTable. Let's see the call to it before we write it. So I'm going to pass into writeTable. Of course, the table with the data we want to write out, its header, and then lastly, I want to pass in a file name. So the file name for us is going to be data_copy.csv. Now, not all CSV files or CSV tables have headers. So what I'm going to do is I'm going to actually move this file name to be the first argument here. And when I write my function header, I'll have file name, table header, but I'm going to provide a default value for header, which is none, in case whoever calls writeTable doesn't have a header to pass in. Then there just simply won't be a header row written. So let's scroll up then and write this header. So file name, table, and header. Following our three-step file processing template, step 1 is to open the file. So I'm going to have outFile is assigned a call to the built-in function open, passing in file name. And then, of course, we need to pass in our file mode. We'll be using W for writing. When you use W as your file mode, if the file doesn't exist, then it will be created. And if it does exist, then it will be completely overwritten. Now, there are other file modes out there. For example, A opens a file for appending, where the file cursor starts at the end of the file if the file exists. So you just start appending to the existing contents, and you don't essentially completely destroy and overwrite them like W does. So take a look at the documentation for open, because you might find that there's a file mode that's better suited for what you need to do. Writing, I'll say one more time, is going to destroy any contents in the file if it already exists. Now let's skip ahead to step 3. I'm going to call outFile.close. Now step 2 is the fun part. What we want to do is we want to walk through each row in the table, and we want to walk through each value in the row, and we want to write out this value separated from the next value by a comma. So I'm going to simply call outFile.write, which accepts a string. So I will pass in value string concatenate with a comma. The only thing is, remember that not all of our values in the table are strings anymore. If you look down here, we converted some of them to be floats. So I don't want this to crash my code when I try to string concatenate a float to a string, or if I try to do binary addition with a float and a string. So what I'm going to do is I'm going to call str, the built-in function, and convert value to a string to ensure that we have successful string concatenation here. Now, outfile, unlike print, it has a method write that doesn't append a new line to the end of the string. So what I need to do is call outfile.write again, this time outside of the for loop, and this will be where I write out a single new line character to denote, okay, I've just written out all my values for a row, a line, and now I'm going to have a new line to prepare for writing out the values for the next row on the next line. So we're not quite done here, but this is enough to run the code and see how our datacopy.csv looks. So go over to the File Explorer and VS Code. Datacopy.csv just showed up. Here it is. So looks like we've got all of our data values. I've ignored the header for now. We'll come back to the header here. But note that we have some issues with our formatting. In fact, we have extra commas on the end, and we have an extra new line at the end. So let's fix those things, and then we'll write out our header, and we should be good. Here's how I'm going to solve this. I'm going to stop my inner for loop one early. That way, I can write out the last value outside of the for loop, and every other value besides the last value will have a comma after it, which is the behavior that I want. So let's change this to use a range. For j in range len row -1, stopping one early. I'll need to grab value now. So this is going to write all of the values with a comma, except it's not going to write the last value. So I'll have to do that outside of my for loop. So I'll do that here in the write statement that I already have. Let's run this and see if this works. Here's data copy. We successfully have removed the extra commas at the end. Now we just need to remove this extra new line at the end. And we can solve this in a similar fashion where we essentially stop our outer for loop one early, and then we write out our last line of values without a new line character at the end. It'll look a little ugly, but we could clean up our solution by writing additional functions. So let's do it. For I in range len table -1, row will be table sub I. What we need to do now then is we need to copy all of our code that writes out a row and do this outside of our for loop. And this will be the code that will write out our last row. But our last row is not going to have this new line character here. And the row is going to be table sub -1. Let's try this. Looks like we have all 5 rows, 001 through 005, no extra comma on the end, and no extra new line at the end. The main thing I'll note is anytime you're copying and pasting in code, you should probably pause and be like, wait, is this the best way to do this? And many times it's not. So what I just did with copying this logic right here was probably not the best way to do this. I would encourage you to take this logic here and put it into a function, maybe something like write row, and then you could pass in a Boolean, true or false, as to whether a new line should be written at the end of the row. So then you could just call this function twice, once passing in true, new line should be written, and then once passing in false, new line shouldn't be written. And then that would clean up this function quite a bit. So as promised, the last thing we need to do here is deal with the header. So let's check to make sure header is not none. If header is not none, then we should have a for loop where we walk through each value in the header and write it out separated by commas. But once again, we don't want that extra comma on the end. So let's do for I in range len header -1. And then we'll do out file dot write. We'll do header sub I, and all of the column names in our header are strings, so I don't need to do a conversion here. I'll put some nice labels in here too, so it's really clear what we're writing out where. Now the only thing we're missing is we need to put a new line character on the end here to prepare for writing out the first row of our data. Let's run it and take a look. Looks good. If I compare the two files, I see they are in fact identical, character by character. This concludes our introduction to writing files in Python. I'll mention that what we've done with write table and what we've done with read table is great for learning how to work with files in Python, especially if you have a custom file format that you need to work with and there isn't an existing parser out there that you could use. Now, CSV is such a popular file type that there are tons of CSV parsers out there that are much more robust than what we've written here. Let me show you that Python actually includes a built-in CSV module that's part of the Python standard library. And you can and should use this CSV module when you're working with CSV files because, like I said, the code we wrote isn't very robust. There are a lot of cases in which it will crash or a lot of cases in which it's not going to properly read in values from a CSV file. So please take a look at the CSV module, and once you're feeling comfortable with opening files, closing files, etc., then start using CSV for opening your CSV files because it can be really easy to get started working with CSV files, and it's much more robust than this introductory learning code we've written today. Thanks for watching, and subscribe to my channel for more Python videos.